Hello everyone, myself Sabina Devi, Assistant Professor, Department of Physics. Okay, in this video, I am going to explain about conditions for total internal reflection. In the previous video, I explained about introduction to optical fiber, right? So, so we know about optical fibers. So optical fibers are used to transmit the light signals. Okay. So in the conditions for so we have 4 to 5 layers in optical fiber. So inner layer is core, second layer is cladding, then buffer jacket and outer coating, right? So buffer jacket it has 4 to 5 layers, right? So these are explained in previous video. In this video, I am going to explain about conditions for total internal reflection, right? So in previous video also I explained about the principle of optical fiber will be the total internal reflection. The light should pass from denser medium to mirror medium. That means core to cladding, right? The incident angle should be greater than the critical angle. Theta I is greater than theta C. So these factors also explained in previous video. So today I am going to explain about determination of numerical aperture and the acceptance angle, right? So numerical aperture. So what is numerical aperture? So numerical aperture is nothing but light gathering capacity of the fiber, right? So sine of the it also defined as the sine of the acceptance angle. So it defines the light gathering capacity of the given fiber, right? So if numerical aperture value is high, means we gather larger amount of light, right? Okay, if suppose numerical aperture is low, means it gathers low amount of light, right? So numerical aperture is the capacity of optical fiber to gather the light waves, right? So acceptance angle. So acceptance angle is nothing but the maximum angle of incidence. Okay. So the below which the light can suffer the total internal reflection. So after that angle only the total internal reflection must be possible, right? So these are all the two main factors in optical fiber. Okay, so this will be determined by using this diagram. Okay, so look at this diagram. Okay, so here it includes three mediums. So first one is air medium, core medium, and a cladding medium. We have three mediums. Okay, N naught will be the refractive index of air. N1 will be the refractive index of core. N2 will be the refractive index of cladding. Right. So now the light wave is incident on core. So at the point of AO, what will be happen? Okay. So consider the longitudinal section of fiber. Let N of N1 N2 or the refractive index of air outside the optical fiber core and cladding respectively, right? So look at this diagram. First, light is enters into the air medium to core medium. Then core then light enters to core to cladding. Then it gets total internal reflection, right? Okay. So now AO is the first point. Okay, light is entered to air medium to core medium. So it has two mediums, right? Air medium and one is core medium. So air medium has the refractive index value N0, core has the refractive index value N1, right? Okay. So in angle of incidence is here, angle is I and here is R. Okay. So look at this diagram. By applying Snell's law, so first let us consider the now at AO light enters into the air medium to core medium. Okay. So by applying Snell's law, it has the angle R is equivalent to 90 degree minus theta, right? Okay. So N0 is equal to sine I equal to N1 sine R. Okay. So N0 sine I is equal to N0 N1 sine R. So N0 is the refractive index of air, sin is the angle of incident angle, right? So N1 will be the refractive index of core and the angle of incidence will be 90 degree minus sin theta. Okay, so applying substitute here, we get sin I is equivalent to so N1 by N0 into cos theta. So sin 90 minus theta will be written here cos theta, right? So sin I maximum is equal to N1 by N0 cos theta C. Okay. So theta C is nothing but critical angle. So I is equivalent to I max, then theta is equivalent to theta C. Then cos theta C can be written here like this square root of N1 square minus N2 square by N1 square. Right? So look at this diagram. So sin I maximum is equal to square root of N1 square minus N2 square by N0. So here the angle will be the refractive air will be N0. Okay. So acceptance angle Imax is equivalent to sine inverse of square root of n1 square minus n2 square by n naught. Okay. So if the medium is an, so it has peak factor index value will be 1. So substitute n naught value will be 1 in this equation. We get angle of acceptance angle Imax is equivalent to sine inverse of square root of n1 square minus n2 square. So we know the numerical aperture is the sine of the acceptance angle. So sine of Imax is equivalent to square root of n1 square minus n2 square. So these two are the equations of acceptance angle and a numerical aperture. So we know that numerical aperture is the light gathering capacity. By using this formula, we can get the numerical aperture of the corresponding fiber. So if we know the values of refractance of core and cladding, then we easily find out the numerical aperture value and the acceptance angle value. That's all. Thank you.